Now, we're doing some addition and subtraction of fractions using unlike denominators. Now here I have two problems. I have the first problem being 5/9 plus 1/3, and the second problem being 2/5 minus 1/3. Now, both of them are fractions. One of them we're adding and the next one we're subtracting. But if you realize, both of them we have unlike denominators. So we will have to work this out. Now, during last week we would have drawn diagrams to show these fractions, and then we would have added and subtracted them using diagrams. Now today we will not be using any diagrams, but we will be working these problems out using the lowest common multiple. Now, I would have said to you before that whenever you're adding fractions and whenever we're adding anything with fractions, the denominators must be the same. And the same thing for when we're subtracting fractions. The denominators must also be the same. So for this problem here, the first one, the denominators are not the same. Because for the first fraction, the denominator is 9. And for the second fraction, the denominator is 3. So we will have to make these fractions denominators the same before we go ahead and start adding the numerators. So in order to make these denominators same, we were using the lowest common multiple method, that is the LCM. Now LCM means lowest common multiple. How do we go ahead finding the lowest common multiples of denominators? Now, a multiple of any number is where we add the number continuously to itself, and it continues adding on and on and on and on and on till to infinity. So these, when you're adding a number to itself, it can go over millions, billions. It doesn't end. So the first one we're going to do, we're going to find the LCM of 9, and we're going to list all the numbers itself. So the first thing we have to do is to put the number 9 down, and then 3. So we're finding the LCM of 9 and 3. Now, in order to find the LCM of this number, we have to add the number to itself continuously. So the first thing you do is to put back the number 9. When you put back the number 9, we had 9 to itself. So it's like saying 9 plus 9. And 9 plus 9 is would give us 18. And then we have to set 18 plus 9. And 18 plus 9 would give us 27. And then we say 27 plus 9. See, if you look at what we're doing, we keep adding 9 to every new product that we have. So 27 plus 9 is 36. Then we say 36 plus 9. And 36 plus 9 is 45. Now we're going to stop here for now, because if you can see, if I continue adding 9, I will, to each new product, I'll keep going and getting a bigger number. Good. So we're going to find the multiples of 3. So we're finding the multiple of 3 now. So the first thing we do is to put back the number 3, and then we're going to start adding 3 to itself. So 3 plus 3 is 6. Then we have 6 plus 3 is 9. Then 9 plus 3 is 12. And we're going to stop here for now. The reason why we're stopping here is because when I look at the number 9, I can see that 9 is there and 9 is also here. So what I realize now, that this 9 is the lowest common multiple between 9 and 3. So I'm going to circle this number 9. So therefore, our new denominator can be 9. So we're going to write back our fraction as 5 and plus 1 over 9 and 3. So remember, the new denominator is 9. So I put equal 9. And I'm going to divide the first denominators into the new denominator. So 9 into 9 will give us 1. Or if you look at when we're finding the LCM chart, if you look at when we find the LCM of 9, we'll see if we count that 1, that 9 is the first number that we got. So 9 into 9 will give us 1. So therefore, we take the 1 and we multiply the 1 by the first numerator of the first fraction. Next, we have to divide 3 into 9. Now 3 into 9 will be how much? Now if we look at the LCM line, we can count and know how much time 3 can go into 9. So we go 1, 2, 3. So 3 can go into 9 3 times. Therefore, we take that 3 and multiply it by the numerator of the second fraction. Now when we find the LCM of this number, we can always circle the lowest or the smallest one, and when we count from the first number to whenever we circle, we can know how many times that number can go into that number. So our new fraction would then be 5 times 1, which would give us 5. I put back the plus sign because remember now I still have to add the numerator. Then 3 times 1, which would give us 3. So now we have 5 plus 3 over 9. So again, I want one answer. So I'm going to put back the 9 to the bottom, and I'm going to add the 5 plus 3, which would give us 8. So our fraction, or our answer, it would be 8 over 9. So therefore, 5 9s plus 1/3 will give us 8 over 9. Now, let's try using the subtraction. Now remember, everything, same thing we did for the addition, the same thing we'll do for the subtraction, except we'll be subtracting instead of adding. So the first thing I want to find out is the LCM of the number, which is the lowest common multiple of the two fractions. So I write the number 5 down, and I write the number 3 down, and I'm going to add these numbers to themselves continuously. So the first thing is 5. 5 plus 5 would give us what? 10. Then 10 plus 5 is going to give us 15. And 15 plus 5 is going to give us 20. So let's stop here for now. Good. Now we're going to add 3 to itself. So I put back the 3 already. So 3 plus 3 is 6. And then 6 plus 3 is 9. Then 9 plus 3 is 12. Then 12 plus 3 is 15. Now I'm going to stop there because I would have realized that the top, I have 15 to the top and 15 at the bottom. So I find a common factor, common multiple. Therefore, there's no other smaller number that's common. So I'm going to circle the 15 for both fractions, for both numbers. So therefore, my newest denominator can be 15. So I'm going to write back 2/5 minus 1/3 equals to 15. That's my denominator. But I'm not putting anything else as my numerators yet because I have to work it out. So I have to divide 5 into 15, and I have to divide 3 into 15. So how many times can 5 go into 15? Let's count. 1, 2, 3. So therefore, 5 can go into 15 3 times. So therefore, because I'll take the number 3 and multiply it by my numerator. Then, how many times can 3 go into 15? Let's count. 1, 2, 3, 4, 5. So 5 times. So I'll take that 5 and multiply it by my numerator. So 3 2s will give us 6. And if you multiply 3 5s, we get 15. Then 5 times 1 is give us 5. So we make a minus sign because we're subtracting, and we put the 5. And then 5 3s will give us 15. So that's why we have 15 there and only 1 15. Now I put equal. What I would normally do, I always put back my denominator first so that it wouldn't mix it up or I wouldn't forget it. Alright? Remember, the denominator remains the same. We're not changing the denominator anymore. So all we have to do now is to minus the two numerators, which is 6 and 5. So 5 from 6 will give us 1. So therefore my final answer would be 1 over 15. Now I hope this is not too difficult for you, but with practice you'll get it. So that's it.